It's a privilege to have Bill Manning from JFrog present to us today. And Bill is a manager of solutions architecture with JFrog. He is also a mentor with Techstars, Matter, and Nest GSV. He has successfully exited 3 companies and took one public in Australia. He is also currently helping various startups as an advisor. In his spare time, Bill likes to travel with his wife and 2 boys. He plays guitar, loves the ocean, and is an avid cyclist. Thank you for joining us, Bill.
Well, guys, thank you so much for having me, and I'm very happy to be here. And today, what I'm going to do is present to you Demystifying SBOM's Impact on Secure Software Development. All right, well, you know what? The idea here is that, we're going to go through and explain the importance from the reasons it's behind it, and also really what it is. Because we always get a lot of questions, about SBOM, especially at my company. Also do a lot of these talks publicly. And the thing is as stated, so I'm Bill Manning, says William, but you can follow me on Twitter, both at JFrog and also on my own personal. Yes, they are my thoughts. But yes, I do run the solution engineering team for the Americas. And today, when we talk about SBOM, we need to start off with the reasons why SBOM suddenly became a thing in the past year and a half. Why did it suddenly, out of nowhere, this big critical thing called software bill of materials, or SBOM, show up? And to understand, we need to start off with the very simple stuff, right? And the way we start off is software supply chain, and software supply chain attacks more specifically. You hear this word a lot, and what exactly does it mean? Well, the thing is we see these headlines everywhere. Right nowadays, you go to Hacker News, you go to even to Google News, and you look in, you'll see, there's some sort of breach, there's some sort of nefarious component that happens, some sort of data loss or whatever. And the thing is that most of the time, this is coming from something that could simply be really rectified very simply over time. But it's about raising awareness, though. The thing is that it's nothing new. The thing is that over the past, this has been going on for a long time. I mean, the thing is that when you look at what a software supply chain attack, it's the basic, simple, most derivative thing that you do as a developer besides coding. And the thing is that when you look through this, you can see over time that there's been plenty of these. And the idea is that somewhere along using those third-party transitive dependencies you use as a developer to build your software and things like that, somebody has slipped into the mix and caused some sort of malicious component or some nefarious component to be injected into the things that you do. Now, when we look at this, like I said, this has been happening over time. This is nothing new. These kind of data breaches, these kind of exploits have been doing. And I'm not talking about some of the other ones, like some of the web exploits and those things about bad coding or improper coding or, those kind of things. I'm just talking about the software utilized to supply what you do as a coder. And the big one that everybody seems to always talk about, and really, actually, to be honest, this was the one that was the catalyst for software bill of materials, which was SolarWinds, right? Back in 2020, March and June, this was a huge thing. Over 18,000 customers were affected. I mean, it was a $100 billion global remediation. Think about that, 18,000 customers. But it wasn't just the customers that of 18,000, it was specifically the customers. And when I say that, especially in the United States, it was people like the Department of Homeland Security, it was the DOD, it was the Federal Reserve Bank, right? These are government entities that were attacked by this. And the interesting thing about SolarWinds was the attack itself. And I always talk about it, and I will say, I do have this morbid curiosity fascination with it. I think it was elegant in its approach, even though the fact that it did cause so much, but the idea was simple. It was actually a 4th level transitive dependency attack, meaning that some developer out there working on this code went in, did a standard pull of a library that they needed. In this case, it was a SolarWinds library. And whoever that was actually constructed, somewhere in that chain of dependencies that developer needed to do their job, somebody slipped in this little bit of code, basically another library. And this library snuck in, got in. And the best part about it, and the elegant part, the part that I was like, this is pretty amazing, even though it's terrible, it's terribly amazing, we'll say that, is the fact that you started it, 14 days later, it did its job. Think about that. It laid in wait for 14 days until it did something, and then it wreaked absolute havoc. But the reason why I bring that up and why this was the catalyst for why so many people were all of a sudden it became a thing was the fact that 85 to 90% of the software you do as a job, as a coder or somebody developing is someone else's software, right? And developers, and I exciting is in the forum right before this, we were discussing it, is I always tell people, and I'm a coder myself, I started my career long, long ago, back in the 90s, right? It sounds funny when I say that, but the whole thing is that we as developers, as coders, are artists, and the palettes we use to create our art is those third-party transit dependencies. I need after I pick a language type to do my job, it could be Java, NPM, Python, whatever, I go out there and I get the tool sets I need to do the task I've been assigned, whether it's a sprint, a KPI, or whatever, and all I know is I need to do my job. And my creativity flows from my ability to want to go in there and do my job perfectly. And I look for those third-party transitive dependencies to do my job. I need something that's going to parse a string. I need something that's going to create a hash table. Whatever it happens to be, I will do a search in the appropriate language that I'm using. I will find that component. I will bring it in. I will use a function to do my task, check it off my list, and continue on. Now, the thing is that we do this with reckless abandon, right? We have this innate naivety on how we actually pull these binaries in without asking the question, are they safe? Can you trust it? And the thing is, like I said, 85 to 90% of your software is someone else's software that you don't know. It's like somebody walking up to you on the street with an open Snickers bar and says, here you go, eat it. All right, that same kind of level of idea. You go, oh, you know what? Do I trust this person? Do I know them? Do I want to eat this? I don't know. So I should probably test it first. But the thing is you got to remember, just because of that, there's other factors you need to keep in mind as you're working through these problems too, is also software automation, because a lot of these automated tools also bring in things. If you're following 12-factor or multi-tier, which is also another thing we were discussing before, is the idea is that your development environment, so using like Docker images to code, do your coding in, should be the same level of environment that you have in your production. But when that happens, one of the other things too is that we've also added in a lot of automated tasks. So the number of things like even Docker images, which have dependencies that have dependencies that have dependencies, they have OS, they have runtime, your application itself. There's lots of things, but when you automate these processes too, there's stuff coming in behind the scenes sometimes that you don't know. Because remember, you have direct dependencies that you've implicitly stated for the things you're doing, but you also have indirect transitive dependencies that come along with it. And as you do this and you automate more, you can kind of lose sight and actually just pull in these ideas that this is all behind the scenes, it's being taken care of automatically. But there's problems there too, because sometimes it actually amplifies the risk in what you're doing. Another thing too is, like I said, all the software built by your company and the software you produce is using stuff that are people you don't know, right? And the thing is that it doesn't really inspire trust sometimes. If something does happen, the fault lies upon the developers, the tool sets, and things like that. And unfortunately, a lot of the practices we go through these days don't really inspire a heavy level of trust. So you need to look at things behind the scenes sometimes to help improve the software base. There's plenty of tools out there that can detect those third-party transitive dependencies and problems, but you need to build a trust level behind the things that you're doing. Also, too, when you're looking at these potential threats and vulnerabilities and you hear all these things about these libraries out there being nefarious and malicious and all that, the thing is some of these have no incentive. Some of them are just for bragging rights, but others are targeted. There's plenty of targeted groups out there that actually do this for money, take down corporations, take down people, extract data, pull that data out, put it onto the black market and sell it. So the thing is that there's a lot of things you need to keep in mind in this crazy world of software development that, in a way, until recently, we've always kind of known. It's been like that unspoken rule that we've kind of known. But now that, financially, this has been so huge and it's actually growing because, just to give you an idea, when we look at this, it's not just, are these potentially threatening things that we're using? Are they potentially going to cause my company harm? And one of the jokes I always make is no company wants to be a headline for the wrong reasons. And there are wrong reasons, such as data breaches. But the thing is not only is it potentially scary, nefarious things that could cause problems, 74% of the stuff you use as a developer is old, outdated, end of life, and also contains always one major vulnerability, but they can also be fixed with a simple update. And this is the thing too, is we'll also talk about levels of remediation, because remediation, the faster you can fix something, the better. And remember, just as a statistic that I don't talk about in here, is that your developers are your frontline defense. So whenever you're doing this, whether you're using my company's tools that we have or any other tools out there, enabling your developers to have this awareness. Because the thing is, if you attack it where it matters most, which is at the developer, or they call shift left. Everybody talks about shift left these days. The thing is that the ROI is greatest there. The closer you get to production, the exponentially cost goes up. So if you get into production, it's like 100x more expensive to fix than something at the developer level. And when we look at this these days, I mean, the stats are there, right? 62% all exploit attacks were from trusted suppliers. For, I mean, from 60, that was a 6.5 per, time increment, from 2015 to 2021, right? Every year it's getting worse and worse. And the thing is that it's getting more expensive to fix these things. But there are more tools in the market, more awareness. But the thing is that just to give you an idea, I mean, supply chain attacks I'm going to explain to you why they're so problematic. Number one, they're low effort. You don't have to be even that skilled to do it. That's the thing is some of these are actually dirty exploits, right? These are things that people cobbled together and put it in. The problem is that these little exploits go in undetected most of the time. As I stated with SolarWinds, it was a 4th level transitive dependency. When was the last time you as a developer looked at the indirect transitive dependencies you brought in? If you're an NPM developer, you have the worst job ever when it comes to this, right? I've done NPM for years. I call it the house party. You have this package.json. Every language has a place where you can define your transitive dependencies. Package.json is NPM. I put 3 things into my package.json that I need to use. Maybe it's a rack framework, maybe it's some sort of parsing, whatever, and 500 transitive dependencies show up. That's why I call it the house party. You invite 3 and a lot more show up. Well, the thing is the reason why they show up like that is it's easy to spread, because once you've gotten into the community, NPM, Maven Central, whatever, and you put these transitive dependencies in undetected by most people, it just spreads. I pull a transitive dependency and say it's a 4th level transitive dependency for a library. It just comes in. They go, yeah, that's just the cost of me doing business. I never ask what that extra one was. But like I said, and the biggest thing is it actually abuses the trust relationship between the company and the consumers, because how can they trust you when a data breach happens? There usually is a huge drop in companies' ability to actually work with their customers after this because of this lack of trust. But the thing is that they can open exploits that are even more, simple than that. It can be a backdoor into services, or it can be just straight up malicious code. The thing is that these attackers just simply blend in. That's the other part of this. Not only developers have this naivety, we also have it. I mean, I'm part of many open source groups. And the thing is, I've been doing it for years. I was part of some open source projects as a product manager and things like that. And the idea here is that we're very welcoming. We want more, the more the merrier, right? The more coders we have in the community, the more creativity it has, the more problems we can solve. It's a very much that mindset of like, yeah, we're doing something, we're going ahead. And the thing is, though, is these are really huge potential threats. And how do these attacks occur? Well, they're very simple. Like I said, I'm a coder. I sit down, I pick, I got to build a product. I've been assigned a task. And, when I'm assigned a task, I pick a language. Doesn't matter what it is. And then I say, okay, great. Based on the requirements I have, I need to have specific libraries to help me do my job. Like I said, parsing a string, creating hash tables, whatever, taking an image and turning it into something. Doesn't matter. But I depend on these dependencies to do my job. So I use my, whatever tool I'm using, I put it together, I compile it, I publish it, whatever I do with the language specific needs, and I create something. But what if one of these components is nefarious? Now, this would be this would be a direct transitive dependency. I implicitly stated, hey guys, remember log4j and log4shell, biggest ones out at the beginning of this year, right? Everybody uses log4j. hugely popular. So I bring it in. Next thing you know, I'm adding it into my code unexpectedly to me. I send my software to my customer. Now they're infected, and we're all happy because now we're all infected together. It sounds like a COVID party. I'm just kidding. Anyway, you get the idea, right? But 90% of the time when this happens, it's actually, like I said, one of these other transitive dependencies, an indirect transitive dependency, something you did not implicitly state. And that comes in on the same idea. Next thing you know, your customer has a lovely set of, vulnerabilities attached to the software you produced for them. And the thing is in 2021, there was a 650% increase in supply chain attacks. Now, I'm not going to lie. I think a lot of this happened to be is that this also started to happen during quarantine. We actually saw the stats rise. People were at home, a little bit bored, had a lot more time on their hands, not really going out. And you know what? Let's give it a shot. And here they are, right? 650% increase. Think about that. That's terrifying. When I read the report from Gartner that brought this up, I was horrified by it. So when software attacks, right, this is really what it comes down to. And the thing is that there's various types. There's things like typo squatting, right? The means is somebody accidentally puts in, E before I instead of I before E. Some really smart developer out there produced a set of malicious components out there. And they do this, by the way. You can look it up, that they put in misspell or mistyped in words. You're quickly typing in, say, log4j, and you transpose one of the characters. Well, next thing you know, you're bringing out something illegitimate. This is very much a real thing. Or dependency confusion. A lot of companies out there release, libraries for you to use, third-party components for you think is from a trusted source, right? Think about that. Okay, you know what? And the example I'm going to use is a real example, right? I mean, big ones. I mean, look at Netflix. I mean, Netflix developed one of my favorite tools of all time. Chaos Monkey. If you ever use Chaos Monkey, it is the bomb. It is so good, right? I used to love using that to do test exploits. But the example I'm going to show you is, how do you know whether or not these libraries are real? How do you actually know? And actually, at the end of the discussion, I'm going to talk about an open source project that we've actually, that we announced to the world called PYRSIA, is a way we're trying to combat this. And we're looking for more people to actually get involved in it. We have some big names behind it, but we'll talk about that towards the end. Because actually, one of the attacks that we actually went ahead and played around with in terms of dependency confusion is PayPal. Think about it. PayPal, trusted financial institution. You know what? People are like, oh, it's a financial payment service. No, it's a bank. Let's face it. If you go down to a PayPal as a bank, bar none. You go online, you're like, you know what? I'm building a secure application. I want to go out and make sure I have the most trusted way to have my users authenticate and have the most reliance. I do a search and I come back with a bunch of libraries that say PayPal. I go, hey, PayPal's a bank. They're regulated. They deal with financial and billions of dollars of financial. You know what? They must be good. I'm going to go ahead and utilize this. You know what the problem here is? These aren't PayPal. PayPal had nothing to do with this. The thing is that this was actually put out there by a hacker group, and they put it out, and actually the exploit was absolutely horrific. It took all that data and shoved it off to some sort of Tor server somewhere and spread your information everywhere around the world. Kind of elegant, I'll admit. Like I said, I have this morbid curiosity with terrible things. Kind of like Tom Waits. I like to sing beautiful songs about terrible things. Same idea. And the idea here is that you need to know what you're utilizing. So why did I talk about all of that, right? Why am I talking about that? And what exactly is a software bill of materials? Let's start off simply. First of all, it's not new. To be honest, it's been around for a while. And actually, the National Telecommunication and Information Administration, in conjunction with the FDA, came and proposed this back in 2018. And actually, its lineage goes back before that. But the reason why this was created was medical devices. Medical devices run on software. And these devices can kill you. And the thing is that we needed to know basically what software ingredients were used in the software to protect itself against exploits and thus, i.e., killing people, right? Think about it. I mean, everything from pacemakers, ventilators, you name it, right? These things operate on software. So the FDA was like, we need to know what's in these devices. And the thing is that this also utilized this to create the framework for what was going to be announced last May by the Biden administration, which is the executive order on improving the nation's cybersecurity. This was a direct link back to the concepts of what happened inside of SolarWinds. The US government actually, I was very surprised, rapidly placed this through. But to be honest, once again, actually, this thing, I did have to read it. I hated it. And it took me like 4 days because it was legalese and boring. But the important part of this that I got to when I read this executive order was this little section right here. Section 4, enhancing software supply chain, right? This idea here, the security aspects behind it, specifically in Article 7 of it, which is provide a purchaser a software bill of materials for each product directly or by publishing on the website. So what this did is this set the stage for anybody who wants to work with the US government. They need to supply a software bill of materials to the government before it can even be considered as a viable entity or viable usage in the government. And variance and change, meaning changes between versions, need updated software bill of materials behind this also. And yes, this was a direct feedback from the government, and this was an answer. Now it's actually bled over into private sector, right? Medical device companies, or just medical in general, any sort of IoT. A lot of this stuff is now becoming a regulation in a lot of other industries. Once again, this has set the stage, and you need to understand when they get asked these questions, it's also going to start affecting things like insurance policies towards companies, right? You need some sort of level of accountability, and this will help. I mean, how many software development teams out there have ever gotten a notification from legal saying you need to provide us with a license diligence report, so this way we can make sure that we're compliant to our company's standards, right? So these are kind of things that one of the parts of the software bill of materials is, of course, licensing. What is the licensing behind this? So it's also a compliance aspect too. But when we think about it, all you got to think about is what I love to talk about. And the reason why I gave this talk before and everybody seemed to laugh at it is the fact that it's simply this. It's a list of ingredients that the FBI already did for years and years around things like food, right? And I like chocolate cake. German chocolate cake is nice too. But the idea here is also not only the ingredients, but also to might contain, right? That idea of here's some warnings that you might have along with it. But this concept is ideally the same thing that you have in the software bill of materials. So let's go take a look at some cake, because cake's more fun to talk about, right? The same idea here. You have a cake on the left, and you know that this cake was made with things, and here's the list of ingredients for the cake. Interesting thing here is, yeah, you know what? Have you ever seen the Great British Bake Off, which is one of my favorite shows? There's always one of these challenges is, here's a bunch of materials, go build something. Same idea here is, I have a cake here. I'm going to show you the ingredients, including the versions, or in this case, the measurements of it, but I've never really told you how to make the cake. And that's the differentiator. This is one of the key factors that a lot of people get wrong with software bill of materials. It's the list of ingredients and the versions. It doesn't tell you how to put it together. So you're not doing any sort of intellectual property loss or anything like that. It's really all the components, all the stuff utilized to make what you do. So a software bill of materials is just like a list of ingredients that are software inside. It can be open source, right? So free, FOSS components, right? Free as in speech, not as in beer, and it can be free or paid. It can be, data restrictive. It doesn't matter. In addition, you can also include other information that might be beneficial to the end recipient of the software, like tooling and environmental information. You don't have to, but sometimes it's nice to put that in to say, oh, by the way, here's some of the things that we did in addition to the components we used to build our software. And the thing is that it's being utilized by, like I said, the government was the first to say, hey, you need to supply this to us. You have no choice. If you want to work with us, you have to do this. And now, by the way, this started off with the US, but now it's actually global, right? The EU has their own thing. APAC is starting to bring a lot of this information online. But really what it is, it's a way for you to go ahead and just provide information from a legal accountability purpose. right? Also, too, it can be used sometimes in negotiations or pre-purposing, or in some cases, sometimes when companies buy software, they actually might start asking this because they might have their own list of things that you can't use. It's like the same thing when you're working with a company. If you have like a firm like we do, and we talk to companies, we use like Google Docs for the way we do things. And sometimes we always have to ask the customer, like, hey, could we share this Google Doc and we can use it together in collaboration? And always hear is, hey, we can't use Google Docs. They've been blacklisted at our office. This is the same idea. You might send this over to them and say, you know what, there's some components in your software that our security team has flagged. Or then we know what, we have some potential threat, if we don't like the licensing behind this component, we're not sure how it's going to affect that. Also, it provides those teams with a way to say, hey, you know what, we know that some of these components in this list of software components that you're using to build your software are on the, we've seen them as being labeled as highly threatening items. Do you have new versions, or what versions of these are available? So they understand the potential of bringing software into the company and the level of acceptable risk they're willing to take based on what you built, using the software that you give them based on what was used to build it. On top of that, though, there's a lot of other benefits too. Identifying and mitigating any sort of vulnerabilities. You can quickly parse through it. Managing licenses. This is a huge one. License compliance. I mean, I went through an acquisition and one of the times, and part of the acquisition process was they wanted a list of all the open source components on the software we created as part of this. And when we went in, we realized we didn't have accountability behind us because they wanted to know the licenses to find out if we had actually used any potential licenses that might cause a problem. Remember, there's all different levels of software licensing, like GPL and all that, and what's acceptable in terms of change elements and things that you do. So some companies won't accept certain licensing. It also allows them to, companies to look through and say, yes, this adheres to our requirements list. Also, too, it allows for more comprehensive information. And in a lot of cases, also, too, there's also a lowering of costs because there's, internally for the company that produced the software and also that's consuming it, to find out if there was an issue and a new version comes in, you can go ahead and see if that component was addressed in the software bill of materials. And then you can assure your customer that you fixed it because you can provide the new software bill of materials to show where that's been mitigated or changed. Now, so all it means is that everything I told you is software has a lot of stuff in it, right? It's got a lot of components. It's got a lot of things. And those things, are libraries and other things. And you know what? We all know our job. And the thing is though, I like to talk about cake. Like I said, let's go back to my cake. I'm actually kind of hungry. I probably should have eaten before this. But at the same time, we'll do a cake. So look at this cake, right? What can you tell me about it, right? We just know, pretend this is a piece of software. Well, you know what? It might be part of a larger cake. We know somebody made it, right? Or it could be, and by the way, it could have been automated too, right? This could have been made in a factory, mass produced and shoved out, right? But initially somebody had to make it somewhere. So this way they could make machinery to fuel it. Same thing as a developer, right? You might experiment with a cake, say, this is a perfect cake. And then you're going to go ahead and put it into some CI process, or in this case, the CI might be cake integration. Ooh, I think this is a new thing. Anyway, you also know that somebody mixed it. It was baked in an oven. I mean, yes, there are cakes out there. You don't have to, but it was baked in an oven. We'll go with that one. Maybe it's decorated. Maybe it's plain, right? And I hope it's tasty, right? I like tasty. But we also know one major thing. There were ingredients here. There were things that were used to make this. So when we look at this, we'll go back to our cake again. You can see there's a list of ingredients here. Now, the thing is that you could include more information. Like I said, if you want to, you could even, some companies might say, well, what are your processes? What are your QA processes? Do you have any validation in terms of performance or scoping in terms of risk mitigation when this product doesn't work? Or is it disaster? Does it have disaster recovery? Can this be highly available if I do things, right? So you could include more information behind it, including like, hey, you know what, when we made this cake before we gave it to you, here's a list of tools we used, and here's the list of the steps that we went through to validate the product before we put it into your hands. You can do that. But also too, what if something changed? And I'm not gonna lie. This example does come from personal experience. What if baking soda? Now, I know if anybody's done, cooking before, and I'm sure at least everybody who's done cooking before has maybe run into one of these. What if you swapped out baking soda for baking powder? right? I have done this. This is not a good thing, but this is change elements, right? So my software bill of materials to reflect that, because the expected results are completely different. Yes, like I said, here you go, done, did it, right? These are the things you need to know, because we need to know what's inside, right? What's inside the software that counts and how you can mitigate some of these risks. So once again, let's go back to our developer, right? Third-party transitive dependencies, pulls them in, creates a product. And what a software bill of materials is those exact entities. We're shoving all that information into the software bill of materials. We'll talk about formats in a second, because there's two different formats of software bill of materials. There's cycle and DX and SPDX. Depending on the organization, they might choose one or the other, but there's two acceptable formats out there right now. But the idea here is that you can now supply a software bill of materials to your customer. There are tools out there that do it. Like my company, we actually, part of the process of publishing your bills into our product, it's Artifactory, is the fact that with our X-ray product, you can extract the software bill of materials easily. There are tools out there that allow you to do this and give it to your customers. Because the big thing is that also too, when you're dealing with your customers and you go to send your next release to your customers, you want to be able to update your software bill of materials, go in, and when you supply that to them, you can do that. Or if there's something nefarious inside, they can also go ahead and find out by looking at the software bill of materials if they're affected without them having to come to you even. Somebody reads in Hacker News that a library is out there, and there's catalogs out there that, software catalogs for software bill of materials. They can do a quick search and go, oh God, are we suspected, are we susceptible to XYZ version 1234 of this library? We'll do a quick search. Oh my God, we are. We have 5 software products running internally that are actually running this. Companies know they can start taking the next step, contact the vendor, take down the software, find out if there's any remediation steps. Can we block that software from being accessible? Whatever. This allows companies to have a knowledge map instead of just having this blank slate. That's what happened with SolarWinds. SolarWinds, nobody knew the ingredients behind the stuff. Suddenly it's everywhere. It explodes, and there's a global catastrophe of epic scale when it comes to this. But also too, it allows companies, like I said, to find out then, how long, say this version of this piece of, the software, maybe how many versions has it been infected in? Well, we find out that version 1, 1.2, and 1.3 have all had this vulnerability, and 1.4 seems to be safe. This is another way that software bill of materials is not just a hindrance, it's actually a helpful method for companies to have even accountability and their customers to have assurances internally that they understand the things they're bringing in. But what about cake with a lot of layers? Right? This is always talking about layered cakes. Each layer could be different. Each one could have different ingredients. Each one can be made independently, right? Each component can be made by somebody else. Together, they might be absolutely delicious, right? You actually might be able to go deliver it to different locations, right? There's all these things and all this information. And the reason why I do this is I always call it the web services cake, right? If you ever use Kubernetes, it's made of many, many multitude of components that are out there. I always like to say the frost is the helm, and then each layer of the cake is Docker, right? And the thing is that each one of these are handled independently, but treated as a whole. And that means that when we look at this and we look at, say, a Docker image, you got to keep in mind, it has an application layer, it has a runtime. The level of complexity in software builds, even in web services or anything you deploy in there, it should have its own software bill of materials too, right? What base OS did you use? What version of the runtime did you use to host your application? What kind of runtime was it? Is your application running a specific version, and what components does that have? And even when we get into something like web services like this, you have maybe different layers of Docker images and even Helm. And you can actually take all this information before you even put it together and even have basically a software bill of materials of software bill of materials, right? Inside of this Helm chart, it calls specific versions of these applications that might be out there. It might be a UI, a data processing backend, and something else. But this allows you to even have accountability behind web services that you should get into the habit of having even internally. Or if you supply a platform to your customers and they have to install it using, say, Kubernetes or any of this, you need to supply the same level of information, not just the individual applications, because you're actually bringing all this in for somebody to use or utilize yourself. And when this happens and there's something bad, this allows companies to go in and directly access that information so they know how they can address it. And remember, The other thing too is you can include things like CI tooling. What CI processes you use. When was it built? What were the stages? What maybe processes were used as part of this? What environments? What were the settings in those environments? And also too, did you detect any vulnerabilities, but you've determined that those vulnerabilities are not applicable based on the context of usage? Meaning, maybe you have a library that's been flagged as a nefarious component. It might have 100 functions in it, and the function that you're utilizing is not the function in question based on the vulnerability, right? The CVE or the CVSS score. Do you really want to throw it out? Where you can include information as a caveat to say, yes, we understand this component is infected, but we also let you know we don't use the potentially nefarious component, and the thing that it exposes, if they ask you, is not part of the process in which we've enabled. So this gives you a lot more information that you can supply to your customers to allow some more assurance in the things that you're doing, and also for even your internal processes and legal teams. Now, misconceptions. I brought up some before. Number one, it is not a roadmap for attackers. Yes, they could infiltrate one of the larger communities, but you're not the only thing that'll be singled out as part of that community, right? It is not a roadmap to say these are the potential vulnerable exploits it might have. You don't have to disclose source code. There is no source code disclosure here. They're not asking you for every level of detail of things they're doing. And then lastly, it's not going to expose any intellectual property. Your sauce is still your secret sauce, right? Do you worry when you make it, say maybe you make a nice tomato sauce and it has all those things of grandma's recipe. You put it together, you sell it to somebody. You might have the ingredients on the outside just to make sure, but you know what? Grandma's recipe upstairs, right? You have that in your head. You're not going to tell that person. You still want them to come back and buy your stuff, right? You don't want them to reproduce it on their own. Same idea. And the thing is that if you need to work with the U.S. government, you need to provide this. This is now a regulation, right? It was actually enacted last November. You also, like I said, it needs to include all the FOSS, right? The free and open source software, or even things that you've even purchased, right? This even includes any proprietary stuff. Also, how, what, and where when it was made, the ability to also do auditing and tracing of potential threats. That's one of the things that actually provides as part of this. Complete accountability behind everything that's been processed, and security and license compliance. This is the legal folks coming after you saying, hey, can you supply us with a list of the stuff that was used in this? Or handing off your software before it's purchased and going through the procurement process. They go through this list and they go, we flagged a couple of things in here that say, our company doesn't think that these versions of these libraries are applicable, and we've actually need you guys to give us some sort of level of assurance that it's okay. Think about this. What if it would happen after the fact? You give it to them and suddenly they realize that you're running something that was not applicable. Do you really want to have to do return on the sale? This will help you address any of those concerns with those customers. And the thing is that you got to remember, when we go back to this, right, I always joke around, and this is like one of the best lines I've ever heard from somebody, right? Every time you pip install, go get, maven fetch, something, you're always doing plugging a thumb drive you found on the sidewalk into your production server, right? And this gives you that level of accountability on the things you're doing. So we have safety and security that we provide other developers and tool sets, and there's lots out there. So remember, software bill of materials is like the endpoint map of what you've done on your quest and your journey. Always protect your organization through whatever means necessary to make sure that you're not picking up a thumb drive off the sidewalk and just be like, oh, this is fine, I'm going to plug it in. So let's talk about one last thing here. This is what I was talking about at the end. We opened up one of the problems that we see in the world today is the fact that there's accountability behind these third-party transitive dependencies. We actually have a lot of backing behind this. There's our site, PYRSIA.io, that you can go to. But what we've done is we've actually gone ahead and we're looking at building and getting people as a zero trust binary network, a decentralized package registry. So in other words, what we're doing is that we're using more of the blockchain style accountability ledger to build basically a series of regulations in a way, or in this case, methodologies that package management, such as Maven Central, NPM, Python, for pip, PyPy, Docker registry and things like that, to have validation behind this so that you can say this is a trusted source package, right? But the thing is, we're calling it a zero trust binary network. And the idea here is it's decentralized, right? So there's no one central source of truth in this case. It's a series of basically ledgers, just like Bitcoin and all that. The idea of the blockchain ledger is pretty powerful. I mean, I've used it in other technologies too. But the idea here is that immutability, is that the validation and the ability to validate. And so this is one of the things that we want to do with verification, by spreading it across and having multiple people actually go in and validate these sources enables trust. And the thing is that we're going ahead and we're going further and further down this. We're getting more and more companies involved. If you want to be involved, go to our PYRSIA.io page. And the thing is that we are going to go ahead and open source this more. And like I said, we're looking for as much involvement as possible. So if you want to start looking at and you want to be involved in an interesting project, I'm super excited about it. And it's very new and it's going to take some time, but we need a lot of hands behind it. But the idea here is that we want to create a bigger sense of trust on the global scale, on top of not just having tool sets that can detect this. We want to go to the root source and try to fix this in a way and have everybody involved so that we have more accountability. And this will actually feed back into the software bill of materials, because we could eventually be able to have a trust ID. This binary was a trusted source and validated. And that's what we're looking to do. So the thing is that if you want to be involved in PYRSIA, please, go to the site, apply and go in, and we'd love to have more people. I'm actually done with this now. This is me. I'm done. I'm Bill Manning. I hope this has been informative. And you know what, guys, thank you so much for having me here and having me part of the conversation. But thank you.
Thank you very much, Bill. That was great. I'm going to go ahead and stop the recording. So if people want to ask questions, and again, this is another reason to join our meetings for the Q&A time. But thank you again, Bill Manning from JFrog.